Billions of years evolution, leading to life's connectivity. Thousands of years of civilization, culmination in smart connectivity. Decades of network transformation, resulting in information connectivity. Connectify is ubiquitous, containing unlimited potential. Networks are becoming the foundation for digital transformation of enterprises. From SDN to autonomous self-healing intent-driven networks, the development of AI, big data, and cloud computing technologies makes all this possible. A new era is coming. Network connects everything. People, machines, data, and get through the digital world and this physical world. Build an engine to unleash their power, help business achieve more. Now we imaginative people grip the chance and one step ahead to rethink network opportunities, to share the magnetic viewpoints, and inspired by each other for our further and a better world. That's why you are here. Welcome to IP Club.
Hi, and welcome back to Huawei's Industrial Digital Transformation Conference. Today, we're going to explore how Wi-Fi 6 is totally transforming industries, and with that, changing people's lives. To kick things off, we're going to hear from Osama Abul-Magd, the chair of the Wi-Fi Standards Working Group, and someone who has been influential in developing the capabilities of Wi-Fi 6. Osama is going to discuss the progress made so far in Wi-Fi standards, and then tell us what he thinks the prospects for the future are. Over to Osama.
Good morning, my name is Osama Abul-Magd, and I'm going to talk about Wi-Fi standard progress and prospects. Just a few words about me. I work for Huawei Technologies in Canada. I joined Huawei actually in 2011, and I am leading the effort at the IEEE 822.11 regarding the development of 11AX standards. And before that, I actually led the effort in defining the 11AC or Wi-Fi 5 standards, if you like. So I have been doing it for almost 10 years, 10, 15 years actually. And I hope I can give you some perspective on why these decisions were made certain way or how the standard evolved to the point where we are right now. The first subject I'm going to talk about is the need for new Wi-Fi. Why do we need Wi-Fi 6? Why not Wi-Fi 5 or Wi-Fi 4? There are a couple of reasons actually that we observed a few years ago, around year 2014. Of course, as usual and as predicted by many studies, the internet traffic is continuing to grow and is going to reach very high levels in the 2020s. And just by next year, the prediction is a large amount of traffic actually will pass through Wi-Fi networks. So in order to do that actually, and in order to accommodate this large traffic, we need to have a new standard, and we need to have higher data rates to achieve this goal. The second reason, and maybe most important, is we observed actually that the use case for Wi-Fi deployments, which traditionally actually been characterized by a small number of APs and small number of users associated to a single AP, like at home or in a small enterprise, actually Wi-Fi is being deployed everywhere. And these kind of deployments like stadium and sporting events, for example, or airports, and these things actually are characterized by a huge number of users, of course, per AP. As you can imagine, actually, in a sporting event, you have perhaps 50,000 people are sitting there and would like maybe to replay some of the events, watch some of the events closer to them using their smartphone, maybe order even food and other stuff, so things like that. Another thing actually is there are some new requirements. The so-called gaming, real-time gaming actually require some low delay. And of course, in factories and industrial application like robots and things like that, this actually requires almost zero loss of information in order to operate these machines. So these were actually the two motivations behind defining Wi-Fi 6. And Wi-Fi 6 actually, it handles dense deployment scenarios, and this is actually the main thing. It focuses on user experience, so that's another important thing. It's not like Wi-Fi 5 or Wi-Fi 4 where we actually increase the overall throughput. We actually focus on we increase actually the total throughput. We focus on the user throughput and user experience, no matter where the user is, close to the AP or far away from the AP. And of course cover really number of usage scenarios like home, enterprise, transportation, IoT. So it's a single platform actually that allows organization to achieve the so-called digital transformation. Okay, so what is the standard status right now? This is what I'm going to talk about next. So in the Wi-Fi industry, actually, you find two main entities that operate on or produce Wi-Fi standards. This is 802.11, which of course you work on the technical standards, like you have .11n, .11ac, .11ax, and many actually alphabet. And Wi-Fi Alliance, of course, which takes the technical specification from IEEE 802.11 and basically focus on the market requirements and decide what features should be introduced to the market first and what features should be introduced to the market later. So if you follow the Wi-Fi industry, actually like 11AC, actually there was certificate AC release 1 and certificate AC release 2, and each one of them included a number of features. Similar stuff actually is going to happen in for 11AX as well. The next actually committee that work on some Wi-Fi standard is Wide Broadband Forum. It's actually related to, it's a Wireless Broadband Alliance actually, or WBA. And this usually has its members belong to the operators, which is very important, of course, to listen to operators, and usually produce things like white papers and things like that. And there are a number of white papers actually very useful related to Wi-Fi 6 on their website. So the situation now actually is Wi-Fi Alliance actually announced its first certification, Wi-Fi 6. Wi-Fi 6 Release 1. It's working on something called Wi-Fi 6E. This is the extension for operating in the 6 gigahertz, and I'm going to talk about that. 6 gigahertz band actually, and it's is also working also on Wi-Fi 6 Release 2, which is expected later, maybe later this year or a little bit longer than that. So things are progressing actually in Wi-Fi Alliance, and many actually, of course, devices got certified on Release 1. So I'm sure you are aware that chips are available in the market for a long time, and access points and so on. So the situation in 802.11, we completed actually what we call working group letter ballot. We completed about 5 working group letter ballot. This is actually where 802.11 members review the standards and submit comments, and we actually responded to many comments and we resolved them. And we are now in what's called IEEE SA, or Standard Association ballot, and this is usually shorter than working group letter ballot. So hopefully, actually by the end of this year, 802.11x specification will be approved and published by the IEEE Standard Association. So we are progressing actually, and we are making good progress on that. So how Huawei is performing in Wi-Fi 6 standards and in the industry in general. Actually, Huawei was one of the main companies, if not the main company, actually operating on the definition of the new project back in 2014. And I got, of course, elected by my peers at 802.11 to chair the effort. And actually, before even Wi-Fi 6, we had in our labs in each quarter, we actually developed the technology to achieve 10 gigabits per second. This is not even having Wi-Fi 6. We developed using over-the-shelf components and increased the number of antennas in order to achieve the 10 gigabits per second, and there were press releases related to that. Huawei, of course, was maybe the first one to produce Wi-Fi 6 access point. As you see here, it's something around 2017. And actually, from my experience, I attended an exhibition in Japan, in Tokyo. It's called the Tokyo Interop 2019 last year, and Huawei actually was connecting the whole exhibition hall using this access point Wi-Fi 6. Of course, the problem was there were no Wi-Fi 6 available device at this time, so nobody can gain from the experience. Like my phone is only 11AC. Yes, and of course, we have a number, like Huawei has a number of customers, of course, signed into our effort and deploying Huawei's access point. Also, it's interesting to note that if you read the first line on this slide, Huawei has submitted 240 new proposals to the 802.11ax committee. And of them, actually 15% of them, this is a good number, actually got included in the standards. Of course, 15%, I'm saying it's a good number because this is a competition between many big companies, actually, not only Huawei, it's Huawei, Qualcomm, Intel, and others. So having 15% embedded in the standards is really a very good ratio. The market view, actually, of course, I'm quoting here from IDC. Of course, it's expected that 11AC is the dominant Wi-Fi technology right now in the industry, but this is expected to change, actually. It's expected that in 2020 and the years after, actually, 11AX and Wi-Fi 6 will replace 11AC, and it's going to be the dominant technology in the enterprise in a few years. Maybe even by next year. In the home area, actually, there is some prediction that in 2 years from now, the home will have up to 50 devices need to be connected. This, of course, adding all this stuff like smart doorbells, smart thermostat, and the like of these devices. So even at the home, where we used to see maybe 3, 4, 5 devices, it's going to be about 50 devices, so it's also against deployment, and 11AX become very important, or Wi-Fi 6 become very important here. I'm going to actually go briefly over the Wi-Fi 6 technology innovation. So what's Wi-Fi 6 basically? I'm just going to mention it briefly. Wi-Fi 6 introduced a number of technical innovations compared to Wi-Fi 5. So we have 1024 QAM, quadrature amplitude modulation. This is a higher order modulation that allows higher rates to be achieved. We introduced actually multi-user support, so technology to support transmissions from multiple users in one time or simultaneously. So this is OFDMA, or orthogonal frequency division multiple access, where you can actually multiplex a number of users in the frequency domain. And also multi-user MIMO, where you can actually multiplex a number of users in the spatial domain, like assigning a number of antennas for each user. Both technologies, OFDMA and uplink multi-user MIMO, are supported in the uplink from station to access point, and in the downlink direction from access point to stations. Also, why Wi-Fi 6 actually introduced the what we call spatial reuse. This allows actually devices in the vicinity of each other to transmit at the same time, as long as the interference from one device on the other is not very significant. So it's imagine the situation where two people sitting beside each other, they can talk at the same time if they have low volume. So this is actually what the spatial reuse. Of course, it enhances the usage of the spectrum, which is very important. Previous Wi-Fi, like Wi-Fi 6 and Wi-Fi 5 and Wi-Fi 6, you cannot do that. Only one device can talk at any time. In order to support low-power devices, Wi-Fi 6 actually different from Wi-Fi 5 can operate only in the 20 megahertz node, so in a relatively narrow channel. So of course, narrow channel will require less power. We also introduced something called target wake-up time, where devices actually can go to sleep or save power in a power save mode until the time comes to communicate with the access point. And last but not least, actually, is operation with 6 gigahertz. So Wi-Fi 6 is different from Wi-Fi 5, Wi-Fi 4. It operates in 2.4 gigahertz, 5 gigahertz, and 6 gigahertz. 6 gigahertz is a new band, actually. It's a very wide band. It's 1.2 gigahertz spectrum. And you can easily actually find wider channel like 160, 80 megahertz channels. You can easily find them in the 6 gigahertz. I believe there are maybe about 10 or maybe even more 160 megahertz channels available in the 6 gigahertz. So using, of course, wider channel will help transmitting more data, so improving the throughput. Also, it will help in achieving low delay as well for low delay applications like real-time gaming and things like that. So this stuff actually can be supported as well. 6 gigahertz actually is not available, as far as I know, not available all over the world. The US, in the US, the FCC is discussing this band, and actually expectation it's going to be available for unlicensed operation, I mean for Wi-Fi, and maybe other unlicensed stuff as well. And it's going to be approved sometime this year, actually. So it's going to happen in the US very fast. As I mentioned, it's 1.2 gigahertz available. In Europe, I believe only half of the band is available, and I don't know. It depends, of course, on regulatory domain by regulatory domain. Having the 6 gigahertz, as I mentioned, will help a great deal in improving throughput and reduce the delay for delay application. This chart here actually show a table comparison between the capabilities of of Wi-Fi 6, Wi-Fi 5, Wi-Fi 4, and I don't think there's anything new here. You can read it on your own. It's just a quick fact sheet about the technology itself. The important thing, of course, as I mentioned, the differentiation is the operation 6 gigahertz, the inclusion of target wake-up time and 20 megahertz operation only for low-power devices, and the inclusion of uplink, downlink, off DMA, and multi-user MIMO. We move forward. So I think now that we talked about Wi-Fi 6, maybe the question is what comes next? Of course, what comes next is Wi-Fi 7. And this is really actually what's happening in the industry. It's just started actually, so there's still a few years, maybe 3-4 years before it materializes. But the first thing actually I would like to emphasize here is Wi-Fi 6 will continue to be the foundation for the new Wi-Fi standards. So any new Wi-Fi standard actually will be based on Wi-Fi 6. Actually, there is an effort underway right now. Just started actually for a few months now to define Wi-Fi 7 or what is called the 11BE. This is the alphabet I'm talking about. The main driver actually for working on 11BE or Wi-Fi 7 is the availability of the new spectrum, the 6 gigahertz. It's wide spectrum, so we can actually define wider channels, wider than 160 megahertz. So we can define actually 320 megahertz channels. We can define more antennas. So these two things by themselves can improve the throughput up to 4 times. And of course, now that we operate in 2.4 gigahertz, 5 gigahertz, 6 gigahertz, there is actually a need for improved performance in multiband and how these multibands work together in order to improve the total throughput of the network. And that's all what I have, and thanks very much for your attention. Thank you.
If we think we know what Wi-Fi 6 is and what sets it apart from earlier Wi-Fi standards, do we fully understand the revolutionary implications the technology is going to have? This is exactly the kind of question that American market research experts Forrester specialize in asking. And we're lucky enough to be joined now by principal analyst Andre Kindness, who's going to help us understand the impact the next generation Wi-Fi is going to have.
Thank you. I appreciate everyone taking time out of their busy schedule to attend this webinar. In particular, I want to thank the Huawei team for inviting me to be part of this event and share Forrester's latest research and perspective on networking. You're probably asking, who are you? I'm a networking analyst for Forrester Research. I've been in and around networking for the last 20 years. However, this wasn't the case. I started my career as an engineer designing aerospace systems that pretty much would derive the complexity and resiliency we see in networking today. Now I work with infrastructure and operation professionals like yourselves to kind of serve up the best practices and base what has worked for other organizations designing complex network infrastructures. I'm here today to dig into the technical and business drivers behind the adoption of Wi-Fi 6. Over the next 20 minutes, I will cover some examples in the verticals and the challenges they're having with them and what Wi-Fi 6 does to solve them. I will also show you the growth and adoption levels based on surveys of companies like yourselves. And then I'll end the session on some best practices. So let's start off in something that we're comfortable with and that we've been talking about for the last couple of years. It's kind of this emerging world of digitalization. But it really kind of started with the realities of this mobile mindset, where laptops and mobile phones unleashed us from our desk and gave us the ability to get what we want, wherever we're at, when we want it. Now you think about that. Now we're starting with the digitalization, enter this new technical dimension of having the physical world wrap the world around us based on our needs itself. You're probably asking, well, what do you mean by that? Let me give you an example. Light levels in a room, or even the temperatures within the room. Having a system respond to your commands, having doors unlock, cars driving out with our input. I'm really referring to this as the emerging digital world, and most of this is going to be done through wireless. In particular, using Wi-Fi and starting off with Wi-Fi 6. What I want to do is kind of give you some relatable examples. I'm going to start something that you're really familiar with. I'm not going to start off on showing you some slides on market growth of Wi-Fi 6 as billions of dollars or anything like that. I mean, honestly, you don't care what the overall value of the market itself. But I want something that's tangible to yourselves. And let's start off with the evolving kind of smart office, the smart building. There's really 3 elements to the modern office itself. We've got the mobility, the smart building itself, and collaboration tools. And start off something that's really familiar is kind of that shifted companies transforming their employees and tools and processes so their workers can be productive and engage customers in their mobile moments, right? And so Forrester research shows that when companies empower employees with the mobile tools, Their employees are 35% more likely to recommend the company's products and services, and 35% more likely to spend time and effort into their careers than employees who are not mobile enabled. And while Wi-Fi 6 will just carry on this, the real power and the benefits of Wi-Fi 6 comes when we couple it with smart buildings, and this even taken to the next level of enhancing worker experience and productivity. Think about that. Sensors for temperatures, lighting, humidity, electrical usage, and occupancy data, right? 2/3 of sensors in buildings today are in light fixtures just to detect human presence in conference rooms, workstation, mobile collaboration rooms themselves, and be able to adjust based on how many people are in there and their needs themselves. Very critical to kind of that employee experience and making them feel better. And then we think about the remaining sensors that monitor data from utilities systems such as HVACs and water pumps and lighting. And then we think about it, they don't produce a lot of data, but as an aggregate of them all, they can create an immense amount of northbound, southbound kind of traffic itself. And something that's new for the campus and branch office is also this east-west traffic that we've talked about in the data center. But it's between the devices communicating in this world. But think about what that Wi-Fi 6 has the ability to deal with these enormous amounts of devices that need to communicate, setting priority and designation levels of who talks and when they talk with these multiple devices. Yes, it's important for the lights to talk to each other, but is that more important than the collaboration tool of someone having a conference with another employee across the world itself? Probably not. So we want to set those kind of things when it comes to the airtime itself. Which then brings me to another thing we need to think about within the office itself and where things are going in the collaboration tools, video, and the rise of VR and AR. Let me give you an example. In regards to VR and imaging, think about 3D product designs, visualization, lifecycle management software, and AutoCAD and PTC Creo. And so when we think about that and we add in the fact is now we're having high security definition cameras being put in everywhere to become mainstream in the buildings themselves, you start to realize the amount of bandwidth that needs to be available in the air to support, AutoCAD and imaging and 3D designs and virtualization, virtual reality, and the security cameras themselves. And this is what Wi-Fi 6 brings to the table, a 40% increase on bandwidth availability over what we saw in the world of Wi-Fi 5. Now, this isn't the only thing that we need to think about and what the value is of bringing, or Wi-Fi 6 brings to the table itself. Take a look let's move into kind of the retail environment themselves. And they've been one of the largest adopters of Wi-Fi, but couldn't do everything they want to do and can't do a lot of digitalization we're talking about with just Wi-Fi 5 in the previous generations when we think about 11A and B itself. When we think about engaging customers using multiple types of technology, shelf weights and mobile points of service and active engagement feedback, we need to have the ability of multiple devices communicating at the same time. And back to my point of being able to have multiple devices communicate and have this environment that's available with multiple users, multiple input, multiple output kind of antennas that you see in Wi-Fi 6, allowing not just 8 spatial streams, but the fact is 8 users to communicate simultaneously. And that's a critical environment when we have the associates engaging with the customers on the floor to be able to answer questions in multiple parts of the building itself, and ensuring that everybody that engagement is just as important in one point as another point within the building at the same time that's occurring. The customers are very finicky when it comes to retail and their experiences around that. And so even having the ability of, when we think what Wi-Fi 6 is bringing, is being able to color the traffic and allow the communication of particular traffic itself and communication services to be prioritized based on that. And we think about it also provides by just coloring it, being able to have the information and manage multiple devices and use the congested area by just using clear channel assessment that we see in Wi-Fi 6 parameters, including dynamic range and power controls. When we think about this in the stores themselves, and customers not having the patience and their devices communicating and making sure that's occurring as they feel like that there's no hindrance of their ability to get the information they want or get what they want in the stores or order the products or carry the product out to stores without some type of hiccup itself. It's such a critical item when we think about the amount of technology that is being invested into the retailers themselves. And one of the elements itself is using cameras as well as location services that's part of Wi-Fi, and blending them together and be able to understand the customer in a little better way. Historically, we thought about just, locations and be able to give information to customers. But we want to know, we want to be able to tie that into the cameras themselves and see the type of customer that they are based on are they male or female, their age group, what are their patterns in the store? Are they just hanging out and they're waiting for somebody else? And you'll be able to tie that with locations and stuff and be able to be a much more intelligent store and retailer and be able to provide that and analyze what's going on and be able to use AI and ML types of technology in the background. Now we start to think about that elements of it. You start to stream in a massive amount of data from these cameras themselves, as well as you're collecting data about the customers and using location services and abilities with Wi-Fi. And ultimately, the fact is Wi-Fi 6 bringing a large amount of bandwidth to be able to enable this to happen in retail locations that historically hasn't occurred in the past. And so we start to see that the ability of Wi-Fi 6 being able to enable the new digitalization that we need to have in stores that take that store and retail to the next level on an intelligence and information to serve the customers and bring a better customer experience within that location itself. But when we think about customer experience and we think about where we're going with digitalization itself, let's look at the opposite end of the retail spectrum. So we have customers in the store itself, but then what about the areas where we don't have customers, where it's just driven by 100% of the employees creating the products or services? And the perfect area on that and why Wi-Fi 6 is so important is one element is manufacturing. So 76% of manufacturing respondents are investing in Industrial 4.0 programs. Many of them are making workers and engineers and plant managers more mobile by outfitting them with mobile workstations, tablets, communication devices, tools, VR headsets. Like, for example, one of the VR headsets is when you're fixing the equipment on the floor, having the schematics in front of you and be able to look for certain parts and be able to adjust as you're working through the machinery. You think about some of the complexities of some of the robots on the floor itself that are building cars, or even the location of the robots itself, and be able to have that information fed to a repair person on the floor that are trying to get the line back up again. And so when we think about the fact is, this increase in mobile devices, almost 50% within the last few years within manufacturing itself, not only does the employee satisfaction goes up, but we think about it when it comes to product quality and higher efficiencies of the manufacturer. Why? Because you're going to be able to recognize quality issues on the floor. Information is going from the machinery, is going to the people that need it. And even the fact is we start to think about the ability of the efficiencies of creating less downtime with this environment. And this is going to be coupled with IoT devices, flow meters, strain reliefs, temperature gauges within these environments itself, even autonomous pickers and delivery vehicles, increasing the speed at which the products are being built because they're picking them and bringing them to the location where they're being added to the vehicle, added to the refrigerator, added to the product that's coming down the manufacturing line. And we even think about the importance of this in the world of the customer that's expecting things to change quickly. We're starting to see robots, we're starting to see manufacturing lines become much more mobile themselves, so not bolted to the floor and the line is being consistent, but the line actually changing based on the models coming down and moving the equipment in and out to new equipment based on what the features and functions of the product needs to be built coming down the line themselves. So we start to see this very dynamic manufacturing location start to move these heavy equipment that becomes much more mobile in this environment itself to be not just more efficient, to produce better quality equipment, but we also think about the realities of being more dynamic and producing products as needed when things start to occur. Now, how does this relate to Wi-Fi 6? Everything I've brought up is a wireless mobile world that I just brought into them. And we start to think about the amount of devices is mind-boggling. I would say it's probably going to grow in this environment by 2 or 3 magnitudes, things that need to be connected over this wireless environment, which then goes back to the ability to communicate to multiple devices at the same time, and having the ability to deal with a lot of devices needing wireless connections themselves. But I would also bring up the fact is a lot of these devices and the headsets or the tablets themselves need to have longevity when it comes to the battery life itself. And Wi-Fi 6 bringing the ability to tell devices to go to sleep and wake back up when the communication occurs. Very important when we're thinking about that you can't just, you're going to take time away if you need to go recharge a device or that the fact that the device needs to be replaced, that's someone walking and changing things out because their headsets or because of tablets or because of workstations ran out of batteries. And so we need to, include that. So having the ability to extend the battery lives from the manufacturing plants becomes a critical importance of keeping the efficiencies up in the plants itself. The other element of it, and really think about what is transpiring, is one of the biggest areas and requirements of low latency communication has been manufacturing. It's been one of the biggest drivers in consistency, and why historically they've been slow on the adoption of wireless technologies outside of or inside the world of Ethernet and Wi-Fi itself, is the ability of having low latency connections. And a lot of it because of PLCs, and a lot of the transmissions by the devices between each other has been built on low latency needs within that plant themselves. And that's what Wi-Fi 6 is bringing to this as well. So you start to think about the environment of the ability to multiple devices, higher bandwidth, more connectivity, allowing multiple devices to connect together, having the ability of more spatial streams within an environment, and even low latency. All those elements that is improvement of Wi-Fi 6 over Wi-Fi 5 or previous generations of Wi-Fi is perfect for the wireless environment inside of a manufacturing site. So what I did probably over the last maybe 8 to 10 minutes is kind of bring up 3 different verticals and what is transpiring in these areas and is driving to the adoption of Wi-Fi 6. In a lot of those instances, I brought up about the devices themselves and IoT, but I really want to put this in perspective and why building on a wireless infrastructure is such an imperative today. If you're looking at the slide in front of you, and on the left-hand side there's a pie. It's the amount of devices, the current infrastructure, and we think about networking as a global area of all the networks connecting things together. Pretty good size number in that area itself, right? I mean, we're talking about maybe about 9 billion devices, servers, storage, printers, access points, mobile devices, phones, laptops. So the ports being shipped around being shipped in existing infrastructure today. And the reality is most ports, virtual ports or wireless ports, are really mobile phones. But look at what happens when we start to look at the world of IoT that's being added to this current networking infrastructure. And I'm pointing to the right-hand side of the screen itself when we look at what's going to be happening by 2025. Now, people have bantered around 10 billion, 30 billion, 50 billion as numbers. Let's just take the fact is we have, including the growth of servers and storage and printers and access points and mobile phones, based on what we've seen in the growth rates, it's been pretty, it's organic, it's pretty linear. It hasn't been anything new in this area to really cross exponential. Where the growth will be coming from is a lot of it is the IoT devices in itself, right? And that's what we need to think about. Is that the fact is we're going to be going from 9 billion to 70 billion devices. Most of those will be inside the building. Most of those will be using low power or personal area and local area network connectivity. A lot has been talked about 5G in this area, but you look at the overall spectrum of most connections will be inside of buildings, will be inside of cars, will be inside of airplanes. And that's a personal and local area types of connections. And we start to see this and think about that inside of a hospital, manufacturing sites, universities and stadiums that need connectivity. Think about that as aggregates and the information that's being connected together and transposed in this environment of needing the amount of bandwidth, multiple types of connections occurring, some of them needing low latency, many of them requiring the ability to conserve batteries in this environment itself. These are all core benefits of Wi-Fi 6. And really, I mean, we think about it, 5 years is not that far apart, that down the road. That's why it's such an imperative to start to build out this wireless infrastructure, in particular with Wi-Fi 6 to support this emerging world that's probably already occurring itself. To the point is, if you're looking at the next slide itself, is we see when it comes to the types of Wi-Fi from, we look at 11 to 11A and B and C, in particular, if we're just looking at Wi-Fi 6 itself, this is why almost, we look at the data, almost 80% of respondents are building out a Wi-Fi 6 infrastructure, right? And because this has been the main thing that we're building in this area itself. Of wireless investment itself, it's more so than cell. More effort's being put into Wi-Fi because we think about it's the most universal wireless technology, consistent all over the world, no matter where you're at. And in general, it's the most consistent way of connecting inside of buildings itself. And so when we think about, the abilities of what Wi-Fi 6 brings to this and the new protocols, OFDMA or QMA, or coloring a multiple user with multiple antennas and multiple outputs with the antennas itself and serving itself, then you can, as we go into the next slide, you start to see why 70% of networking and telecom professionals themselves indicate they're implementing, expanding, or building out their Wi-Fi 6 infrastructure of Wi-Fi. So we have Wi-Fi being the main medium for connectivity across not just mobile devices. When we think about stationary devices, we think about really the aspects of what even IoT and those devices and security cameras that needing a large amount of bandwidth, or maybe mobile point of service. They're not connecting through Bluetooth or Zigbee, they're using Wi-Fi. And so when we think about the fact that we have Wi-Fi, then we realize the importance of this new digital emerging world itself is why Wi-Fi 6 is such an important ingredient of shifting us from this mobile mindset of just dealing with mobile phones and laptops to dealing with a very connected world around us of physical and electrical devices supporting our immediate needs in this area itself. And so that's why it shouldn't be any surprise, and maybe it's a few to you, why there's, back to the point of almost 70% of networking organizations are already building, implementing, expanding, or looking to, within the next 12 months, to build out their Wi-Fi 6 infrastructure. All right, so maybe I've convinced you that Wi-Fi 6 is important. But how do you do it? What do you do? What are the approaches? This is probably not the right forum or long enough to talk about all the technical aspects, but I wanted to bring up some best practices I consistently hear around technology that comes up a lot, both on the Wi-Fi and Wi-Fi 6 area itself, but in general, that seems to be completely forgotten in each one of our projects. And so one of the first ones I want to start off with, and I want to hammer home on, and a lot of people and organizations struggle with this, just network strategy, but in particular a wireless strategy. And a wireless strategy that mirrors the business strategy. And many of you have said historically, and I've worked with a lot of clients, that I can't predict what's going down, 6 months, 12 months down the line. I guarantee you. The business is creating a strategy that 2 or 3 or 4 years out, they have to make some guesses. You want to make sure you're doing the same thing and try the best to do that, because what you're going to be adding, how you're going to build out that Wi-Fi infrastructure is going to be supported. You're not going to change it out within the next 5 years. It's too expensive. So you want to make a best guess and look at the devices and things happening over the next 5 years, and which brings me to bullet point 2. The amount of devices and the amount of applications and things, we're going to have to extrapolate. We're going to have to think about the ability and the information that's going to be transpiring over this years. And go out to each group, go out to the businesses and pull in that type of information and see if you can make a best guess on the application growth, the bandwidth needs. Take over the last 5 years what's occurred. Then add in the factor probably IoT, which will cause the amount of ports to grow by magnitude or more at the network edge, virtual wireless ports, by magnitude or more. Use that as a multiplier to the applications and services, and when we start to think about the amount of devices, the amount of bandwidth needed. And then we can take that and use that as our method to deploy the right amount of access points out there, and in particular make sure that the amount that's covering today of Wi-Fi 6 enables that support down the line, because you don't want to be moving access points 3 years down the line to adjust and put more in. The cost will be much lower if you overbuild now than trying to make adjustments later on. And I would even say one of the things to think about is to look for those partners out there and those vendors out there that really simplify the management of it. Wireless and Wi-Fi, we have a world that's getting more complex. Do they have the ability to have information, have machine learning, artificial intelligence built into it, have GUI interfaces, have things that simplify the setup and management and the configuration of it, even the troubleshooting of it, a very simple interface, and making things your life easier and automate some of the things out there. But one of the bigger things too to bring up is, does this vendor have the ability to support some adjacent technologies? Whether it be Bluetooth or Zigbee, that's going to be part of your environment. And what I mean by that is not just managing them, but having those interfaces and those network management and monitoring capabilities of understanding that's part of your network and seeing the visualization on the screens themselves, and not just identifying it as a noise being caused by it, but actually it's a Bluetooth beacon, it's part of yours, and maybe you need to make the adjustments on it since it's in a 2.4 gigahertz range. And the fact is Wi-Fi 6, unlike Wi-Fi 5, goes back and uses the 2.4 gigahertz range to have more bandwidth, to have more spectrum available, which helps the overall ability to support more clients, and bandwidth is to be able to use a 2.4 and 5 gigahertz range. Now we think about that, about Zigbee and Bluetooth and other wireless technologies being in that area. So having an understanding what the other technologies are doing and how they operate within that spectrum itself is part of the overall management, is a critical piece of it. And the other thing I would add to this is it's not going to be an easy transition, and just buying the products is not enough. Please invest in the skills and education. The multiple users, the OFMDMA, multiple users and multiple input, multiple outputs of the antennas themselves. Just Wi-Fi 6 is a little bit more complicated, and the skills understanding of it needs to be updated, and spend the money to send your networking professionals back to school, get them updated. The education is around that. And at the same time as use that for other technologies, because the mounted devices, the prioritization of the devices, the ability to set up this spectrum and create a ubiquitous wireless, specifically a Wi-Fi infrastructure to support the digitalization of your hospital, of your manufacturing site, of your retail becomes critical, and a lot of it depends on the skills. It's been a biggest hurdle historically with any networking project is typically the skills are not in place. So while you're looking at to build out your Wi-Fi and build out the door, or even deploy it and design for your Wi-Fi 6 infrastructure, this is the time to invest in skills and education in parallel at the same time to make sure the team is ready for this emerging world itself. I hope this was beneficial in providing some of the best practices and the value behind what Wi-Fi 6 brings to infrastructure and why it's such a critical need to incorporate it and to put a plan around it to build it out for your emerging digital world, and especially the emerging digital business that's happening inside of your business. I'm Andre Kindness, Forrester Research. I appreciate your time. Thank you very much.
Hello again. Campuses are the places where we live and work. And our cities are nothing more than a collection of campuses connected by roads. That word connection is key because today, more than ever, connections across campuses and between campuses are critical. These connections must be reliable, they must be efficient, and they must be fast. Henning Czerny from Huawei Germany can tell us more.
Hello, my name is Henning Czerny. I'm Vice Director Networking Solution Sales of Huawei Germany. Today I want to talk with you about how to build a high quality and innovative wireless LAN campus network. Campuses with different functions are converged into a city. In other words, a city is a campus except the roads. What do we call a campus? Office and production parks, for example, where 90% of the people work. They account for 80% of the GDP. Various industrial IoT terminals are connected there as well, and after work, people enter a commercial park, such as supermarkets, cinemas, or go to football games with friends. They are all also some kind of campuses. And finally, most of the time, every one of us is in or on a campus. Campuses are ubiquitous, but they have different functions and have different requirements on the network. New technologies such as mobility, big data, artificial intelligence, and Internet of Things and cloud computing are accelerating digital transformation and the upgrade in various industries. Digital transformation exerts a great impact on sustainable development of enterprises. Enterprise campus networks are the cornerstone of the digital transformation. Nowadays, BYOD, mobile office, cloud computing, software-defined networking, IoT, AI, big data, and also kind of stuff is gaining momentum. Driven by this, new technologies and applications are constantly emerging and are making inroads to enterprise campus networks. Huawei Cloud Campus solution adopts a new philosophy of intent-driven network. We call it IDN. And it introduces big data analytics, artificial intelligence technologies into cloud and software-defined networking. It helps enterprises to build intelligent, simplified, converged, open, and secure networks. We have found that the wireless network is becoming more and more important in office work, especially in campuses, including office and production networks. In general, we have a high requirement for the wirelessization of office telephones, manufacturing and production processes and services. For example, in higher education and general education, we can see that we want to enjoy high quality teaching anytime and anywhere. This is a basic requirement of various teaching and education industries. In the office field, we have made great efforts to implement remote office and large-scale offices. If we can see that the demand for wireless office is increasingly strong, including the requirement for screen projection and the access of mobile phones and laptops. It is a trend to implement wireless office. In terms of retailing, how can we integrate various short-distance wireless IoT technologies with our current Wi-Fi 6 technologies to form a set of network management to support various production processes, including retailing, manufacturing, and logistics of shopping malls and supermarkets. All these are wireless requirements. Therefore, wireless transformation is an important network basis for digital transformation of enterprises. It is necessary to build a better network basis to meet the wireless requirements of various enterprise campuses. On a traditional campus network, wired, wireless, and IoT services are planned, deployed, and managed separately and independently from each other. As a result, the overall network construction cost becomes high, and the workload of network management and O&M increases exponentially. Huawei APs integrate IoT modules to provide functions of IoT base stations, implementing converged and simplified management. Huawei wired and wireless convergence technology provides unified wired and wireless management and experience. In traditional mode, you need to manually configure devices one by one through command line or web interface. For large-scale campus networks, manual configuration workload is heavy and configuration is very complex. As new services go online, dedicated service networks need to be deployed and devices need to be deployed one by one. The deployment period is very long and the cost is extremely high. In traditional mode, policies oriented to users and services are managed based on VLANs and access lists and need to be manually configured. The maintenance workload is heavy and the network deployment efficiency is very low as well. Huawei HI Controller Campus uses centralized network automation configuration and management to provide customers with fast and low-risk device deployment and service provisioning experience, thereby implementing intent-driven networks. Huawei Free Mobility Solution manages user policies based on users and groups, compared with policy management based on VLANs and RCL. Management based on user group is much more simplified, which simplifies policy configuration during network deployment and capacity expansion. Huawei virtualization technology allows multiple virtual networks to be created on the same physical network to divide multiple self-service networks, implement user and service isolation. In traditional O&M mode, the network management systems can monitor just the key performance indicators of the network, but it cannot detect specific user experience. As a result, IT personnel can not identify network service faults in a timely manner. It is nearly impossible to quickly locate a fault when the fault occurs because it depends heavily on the O&M personnel skills to identify the problems. As, for example, a network indicator deteriorates, IT personnel have to use traditional O&M to evaluate network status and deploy specific customization policies and do troubleshooting. The network is not self-optimized because it relies on the personnel to analyze and fix the problems. Based on telemetry technology, Huawei Campus Insight implements data visualization based on users, applications, user experience, and time to identify faults and locate root causes, improving the user experience. Organizations that are going beyond digital offices only. Digital production and operation require a multifunctional all-wireless network that can quickly connect things and environments and people together, such an advanced network delivering low latency and zero packet loss, which is mandatory for real-time decision-making applications and which implements end-to-end automation covering design, deployment, service provisioning, and optimization. The Huawei Cloud Campus solution is the ideal choice to accomplish this. It adopts cutting-edge wired and wireless, big data, AI, and cloud technologies to build experience-centric campus networks that deliver ubiquitous connectivity, unmatched service level assurance, and a very smooth evaluation. With unrivaled networking capabilities and openness, Huawei's Cloud Campus solution enables digital transformation across all industries. Cutting-edge wired and wireless network technologies, including 5G powered Wi-Fi 6, the first cell switching technology, and wired and wireless convergence services, Cloud Campus helps to construct an experience-centric network that is focused on the user with non-blocking, large capacity switching, ultra-low latency, and zero packet loss. With graphic user interface and the most service-rich young model, Huawei Cloud Campus solution automates network design, deployment, service provisioning, and O&M across wireless LAN, LAN, and wide area network to support faster service rollouts. Powered by AI and machine learning, the solution delivers quantifiable experience assessments, proactive identification and remediation of potential faults, and dynamic discovery and proactive defense of unknown threats. Huawei's Air Engine portfolio fulfills all requirements of modern campus networks, regardless whether we are talking about office, education campus, production site, or whatever else. Access points with 10 gigabit bandwidth or even higher, ultra broadband wireless access controllers, and quality of service, delivering per user and per application assurance across the full process from AP management to user experience guarantee. Huawei Wi-Fi solution is an autonomous driving network, adaptive to scenarios and terminals with automatic network planning optimization, network health self-check, automatic fault locating, and basic self-healing capabilities. It is easy to manage and scalable to all enterprise scenarios. Huawei Air Engine access points have an industry-leading smart antenna design, which increases coverage distance by 20%, and signal interference can be reduced by 15%. That ensures signal quality for terminal devices and is perfect for environments where devices and obstacles are moving frequently. Some advantages have to be mentioned. Smart antennas can dynamically adjust the signal coverage direction, enabling the signal to follow the users when they are moving. Additionally, smart antennas can concentrate signals to provide stronger penetration capabilities and extend coverage distance. We are frequently talking about convergence, for example, in data center environment, but convergence is very beneficial in office environments as well. Normally, you have to build separated infrastructure for Wi-Fi and several proprietary IoT applications in parallel. With Huawei Air Engine access points, you can converge all these infrastructures into the wireless LAN access points. There are so many use cases that we can offer today, like in healthcare, in smart building, electronic shelf labeling for retailing, for example, and asset tracking. This WLAN IoT convergence saves OPEX and CAPEX by eliminating other proprietary IoT infrastructures. But because of the innovative and modular design of the access point, you can even implement future applications, which makes the infrastructure future ready and it offers a huge investment protection. And Huawei Cloud Engine S12700 is the next generation campus core switch offering higher reliability by achieving non-clocking switching and zero packet loss in high concurrency. Heavy load environments by leveraging Huawei's solar chipset and innovative cell switching technology. It is easier to manage by converging wired and wireless network from access to core, managing up to 10,000 access points with a single switch and simplified O&M with unified user authentication. It implements plug-and-play across the network, enabling deployment and adjustment in minutes. And it responds to service changes in real time with software-defined networking and VXLAN technologies. In the future, networks will be autonomous and self-healing networks by collecting and analyzing massive O&M data related to the network. Operators can improve service operation and efficiency and provide unprecedented user experience. However, IT O&M personnel today is still using traditional network management tools to manage and analyze network problems, which is a massive response. What problems do occur when? What is the main problems user are? Where is the problem coming from? What is the root cause? These are the still the needs of O&M personnel. And how to solve that? Therefore, some very innovative technologies are urgently needed to solve the current network and user experience problems. The O&M management of medium and large-sized campus network is handled over from IT O&M to machines, and the network status and optimization suggestions are predicted in real time through machine learning. In this way, warnings are provided or even problems are automatically solved for IT departments before employees and customers encounter the problem. iMaster NCE is the brain of Huawei intent-driven network. It integrates the network management, control, and analysis functions. iMaster NCE consists of 4 engines: the intent engine, the automation engine, the analysis engine, and the intelligence engine. These 4 engines interact with each other, allowing Master NCE to provide open northbound APIs to receive business intent as well as collect network data in real time through telemetry. This is building a digital twin based on unified data modeling. So Master NCE leverages AI and big data to verify business intent and implement proactive O&M of physical networks, implementing intent-driven service automation. It also achieves real-time awareness of network status and performance predictive maintenance. Master NCE is designed for scenarios such as data centers, enterprise campuses, enterprise private lines, making networks more simple, smart, open, and secure, as accelerating the enterprise service transformation and innovation. What is the Master NCE? Huawei iMaster NCE is the industry's first intelligent network automation platform that integrates management, control, analysis, and AI capabilities. Huawei Master NCE effectively bridges the gap between business and the physical network. Driven by business and service intent, the NCE implements centralized management, control and analysis of the entire network and enables resource cloudification, full life cycle network automation and intelligent closed loop management based on data analysis. To quickly integrate upper layer IT systems, NCE provides open application programming interfaces, so-called APIs as well. Where can the Master NCE be used? The Master NCE can be used in enterprise data center networks, enterprise campuses, what we are talking about today, and enterprise branch interconnections, so-called SD-WAN scenarios, to make enterprise networks simpler, smarter, opener, and more secure than before. Campus Insight, as one part of the NCE Campus Network Analyzer, uses telemetry protocol technology to collect clients' user experience metrics in seconds. With Campus Insight, you can view the full journey of each client on the Wi-Fi network in real time. Once a user occurs an issue, you can trace and identify the full journey of data of the client to determine where the issue is originated. Campus Insight intelligently analyzes collected data based on big data and AI algorithms to effectively identify 4 typical types of issues: connectivity, air interface problems, roaming, and device issues in Wi-Fi networks. In addition, Campus Insight can analyze the root cause and provide troubleshooting suggestions for group issues and individual issues. Through proactive O&M, this effectively reduces the complaints of campus network users and reduces networking OpEx. Huawei Campus Insight changes the traditional monitoring mode that focuses on resource status. It uses telemetry technology to analyze network data in real time, uses big data analysis and AI algorithms to learn the network behavior, and it detects the network experience of each user in real time, within seconds. Based on that, Campus Insight can accurately identify more than 85% of network problems, helping the IT O&M personnel to quickly identify faults. In addition, the solution proactively predicts potential network faults and builds excellent network service experience, effectively reducing OpEx by more than 50%. Let me introduce a use case to you. Real-time applications like video and audio streaming have high requirements on the networks. Troubleshootings of this kind of applications is difficult by using reactive technologies as it is used today. With Huawei Campus Insight, it is totally different. It offers proactive detection of the audio and video quality through SIP snooping technology. The analyzer proactively senses SIP and RTP audio and video streams, detects the setup and teardown of audio and video sessions in real time, and automatically uses the EMDI technology to monitor the audio and video stream quality during the whole session period and identify poor quality audio and video streams. By that, it can analyze the root cause for poor audio and video quality and unexpected session disconnections in real time, including roaming exceptions, Wi-Fi disassociation, signal problems, and many, many more. In this case shown here, the O&M personnel checks the audio and video session list in the office area and finds out that the session quality is poor for a client. After checking the poor quality session details, the O&M personnel finds there is a large number of packets are lost on the access switch port of the client. The correlative analysis result of the access switch port KPI shows that the port is congested. After the traffic rate limiting is adjusted and the port congestion issue is solved, the quality of video and audio sessions become normal again for this client. So let me summarize our vision for campus networks. We are talking about zero packet loss for key services even when network congestion occurs. millisecond level fast forwarding on air interfaces, super fast roaming, CLI-free simplified deployment, service provisioning in minutes, proactive service experience assurance, automatically demarcate and locate as well as proactively repair and optimize network issues, highly reliable wired and wireless connections, network-wide security collaboration and borderless proactive defense. Thanks for watching.
Welcome back to Shenzhen and Huawei's HQ. We like to say that you should only buy a parachute from someone who's willing to jump out of the plane with you. And you can rest assured that Huawei's own campus is built from the very technology that we are constantly looking to refine and innovate. Let's hear a little bit more about that from Daniele Mantovani, CTO of Huawei Enterprise.
Hi, my name is Daniele Mantovani. I'm the CTO of Enterprise Business Group in Italy. In this session, I'm going to give you an overview of Huawei all-wireless campus digital transformation. So we will go through the experience of Huawei in this segment. If we see the analysis done from Forbes and Accenture, we see that 84% of the company failed in the execution of the digital transformation. And most of this, the reason is due to the lack of skill that are acting as a barrier for this digital transformation. So there is a problem of culture and how I make the organization to have the possibility to learn more on what is about a digital transformation and the collaboration among all the people in a team to make more efficient the collaboration. So in this session, we will analyze what Huawei has done for the digital transformation of all wireless campus network. As you know, Huawei is a company with more than 180,000 employees. We have more than 1,000 offices in more than 170 countries. And we have more than 400,000 wireless terminals. To give you an idea of the number, in our offices we have each day more than 2.8 million emails, more than 80,000 conference calls per day, and 200,000 warehouse order sent each day. We have 600 apps, more or less, and the organization is between office and production. In the office we can find PC, cloud-based printing, intelligent access cloud, electronic whiteboard, etc., etc. In the production, the IoT environment with the access log, post machine, etc. All the wireless network is divided in 3 SSID, one for the employee, one for the guest, and the other one for the IoT. Through this digital transformation, we achieved a 30% increase of the efficiency, and we reduce 80% the cabling, being more agile in opening new offices or moving into new offices. How to measure the digital transformation? We have what we call ROADs. So real time, so a network need to be real time, everything on demand, all available online, with a do-it-yourself approach for a service provisioning and service orchestration, and social. The network need to be intelligent, as we will see later, to improve and have an intelligent optimization and intelligent operation and maintenance, service-oriented for a fast provisioning and elasticity and agile for when we have to change and move the office, put at the center the user experience, so experience first, moving from a concept of KPI to a key quality indicator, scenario-based and overall all wireless. So this is an example of some of our applications, so moving from mainly Wi-Fi to all wireless approach, with all wireless office endpoint, so with the Ethernet replacement, and moving to mobile printing, laptop, mobile phone, tablet, all wireless VoIP for the collaboration with the video conference live broadcasting with our solution, which is Rethink. The wireless meeting room, everything is very simple and easy to access, and the convergence between IoT and Wi-Fi, achieving the access management, energy management, and intelligent access control. So this is an example on how we easily enjoy the meeting in a meeting room with the possibility to have electronic whiteboard with a simple one click sending meeting minutes to the mailbox of the participant, wireless projection, so I can project my slide in really few seconds, and joining a conference call using my mobile phone with the QR code. As I was mentioning before, experience first, put the person at the center, and moving from a KPI concept to a key quality indicator, and mapping different type of services with the key quality I need to achieve for the end user. For example, for the voice conference, I need to have an initial buffer of a certain amount of packet. These key quality indicator then are mapped into the KPI. And this is another example. We receive a lot of guests in our headquarters, and we want our VIP guests to have the best experience from the moment they enter, with intelligent access control, with the possibility to have the face recognition, VIP identification, and intelligent access control, intelligent welcome with VIP welcome message and the campus navigation map, the Wi-Fi network with the QR to access easily to our Wi-Fi network as a guest and to set up the VIP QS setting, the technical workshop and the HD video conference simply using the QR code enabling the access to the video conference or to the technical workshop with the setting up of the bandwidth and the video app identification. The enterprise exhibition hall access to get the right into this environment, and when they leave, usually we have the photo gift for our VIP customer and the reception feedback that we collect from our customer. The other point that we discussed before was the scenario specific. So what we want to achieve with this is the possibility to standardize a specific scenario and to have one scenario with one policy. So to have a service model, through the service model, we design standard, and from this we map the specific scenario with the specific policy. This will allow us basically to move the office, to open a new office with reducing the time from 2-3 months to 2 weeks. So this is quite important for the efficiency and for the agile approach we have for the digital transformation of our network. The other point is the service-oriented solution. We implement a network as a service type of approach with a cloud-based network architecture and the service that are decoupled from the network, as we will see in the next slide. So we will have a network deployment for massive site, for R&D office, rep office, open lab, retail store. The multi-purpose network with office, R&D network, and as we will see, different zone, different virtual network access. The network serviced instant provisioning for guest Wi-Fi, proxy permission, bring your own device, etc. Massive site management, this is quite important to keep control of the overall office we have all over the world, for remote site device replacement, traffic visualization, remote fault location, and remote fault fixing. And then the innovative service like asset management or terminal configuration and traffic statistics. This is the concept I was mentioning before. So the concept to have one physical network, and in our case we have 4 virtual network. We call it red for the chipset department, yellow for R&D department, green zone for non-R&D employee, and then the blue zone for everything else like the guest or like the consultant. We create the network isolation between these different departments with independent policy and different security area and security policy for each of these. And with a simple one click, we can change the policy and changing a red, for example, a red zone into a green zone, or changing the policy of a specific zone. The last point is the intelligence. Intelligence with the real-time user experience awareness, implementing intelligent network optimization and fault location. Here we apply artificial intelligence, for example, to predict the fault and the capacity needed in our network. We have real-time user experience awareness for visual user experience, roaming quality, etc. Intelligent network optimization and intelligent fault location and rectification. So the objective is to move with reducing the response time to fault from hours to minutes. And in this way, with this approach, we increase, basically, we identify 85% of the potential problem, so we predict 85% of the potential problem, and we improve the operation and efficiency by 30%. And here on the left side, you can see the percentage of the issue we had in 2018, with 37% of the 5,000 faults we had in our network was mainly due to the wireless issue that we prevent to have issue in field. Application problem for 31%, wired issue for 18%, and device issue for 8%. So, with this type of approach, we increase the efficiency and we reduce the time to set up new offices. Thank you very much for your time.
We've talked a lot about Wi-Fi 6 and how it's changing industries and enterprises across the board. I don't think we want to go any further without first learning some specific examples where this is the case. Victor Jimenez from Huawei Spain is waiting for us now.
Yes, in this presentation we are going to see how the technology of Huawei for the Air Engine Wi-Fi 6 can solve and present new challenges for the industry, okay, as a new tool for many of the applications. Okay, as we know, since the industrial revolution 18 centuries ago, the technology has been a major driver for all the transformation that go through the years. Okay, now we are in a time where what we need is a change in the paradigm of the industrial process. Okay, it includes first the organization, how they work. Okay, we begin to focus just on the production area, different units. Now we need to move more to a learning organization that is able to understand the different process and begin to progress also with the demanding of the market. In the past also was very focused on a single use. One people or one production chain just focus on one function. It can no longer be seen this way. Now you need to see the end-to-end of all the process. Okay? Also in the past, factories, special factories, was located in a special place. Just one place. You just care about that. And now we need to think on the production and work of many different areas, even across the globe. So we are considering now global challenges. Okay, so these are the kind of things that the Wi-Fi 6 technology and the Huawei solution for Cloud Campus can help to solve. Okay, especially in the case of the Wi-Fi 6, we see that it attacks some of the key features that we need to move on the technology for the industries and factories. Okay, we attack this on three different angles. One is the better bandwidth. Okay, better bandwidth, more bandwidth. You can introduce more data, more speed. Okay, on the different environments. We can see things like 8K. We can see things like virtual reality. We can see things like augmented reality that consume a large volume of data, okay, that with the previous technologies, Wi-Fi or other technologies that one uses in the industry, was not possible to manage all that kind of information. Okay? On the other side, we also have a new issue to attack, that is the massive number of units and elements that we need to manage. Okay, we're talking about especially IoT. We are talking about location on the different elements that can be in the industrial manufacturing process. We're talking about also still the people that is moving on the location, and that every time the networks are bigger and bigger. So this is something that is better for Wi-Fi 6 that was in the past for Wi-Fi 5 or the previous technologies. More easy to manage this high density occupation of the space. And also very important when we are talking about a new generation of industrial processes that are focused on automated elements like robots or AVGs. Okay, in the case of the AVGs, in the case of the AGVs, okay, these are vehicles that are focused on move different kind of load inside the factories or the warehouse at a speed that is higher and more efficient than any human controlling a machine. Okay, later we can see an example of that, but this is the typical Amazon robot that is going to the floor, moving boxes. Okay. For these kind of elements, we need a very, very low latency, okay? Because you cannot wait from one device to be connected and then disconnected and connected from the network, because you will lose the synchronization of all the system and all the factory will be stopped. Okay, let's see now in detail how the Wi-Fi 6 can help to reshape the working space, in this case for the human users, okay, not just the automated. Okay, this is a good sample. This is an example that we get inside from Huawei. That is a very large company. Okay, and we have very important industrial processes where we need people checking this. As we mentioned, now it helps to collaborate better because we provide the bandwidth, we provide the efficiency that allows the people, okay, to improve this efficiency. As we can see here in the numbers, we can increase our satisfaction in the work. Okay, the people that is using our data connections from 85% to 90%. Okay, it doesn't look maybe so much, but when you count the number of users and the load of work, this 5% can be really, really significant in the savings that we do and the improvement in the production. We also can have more usual uses, like can be meeting rooms or some office space. But in the case of this, is not just have a nicer Wi-Fi. It's also that we can add different kinds of sensors and uses like IoT for the temperature of the room, like the lights, intensity of the lights, the speakers, the screens. All of these you can integrate now with Wi-Fi 6 to the wireless network, different than we do in the past. So the experience of the user of these rooms can also be richer. Okay? We also can see something similar in more normal working spaces like the cubicles for the people, where you can we can move or totally avoid the use of cabling. Okay, so we can go to a pure wireless environment. Okay, it makes easier for entering into production. Okay, you don't need to care too much about cabling all the system and then begin to work. You can go directly to work for these spaces that maybe need some constant transformation in the space and the use. This can be a very, very good solution because now you have the bandwidth necessary to achieve this and also the density to achieve this. Okay, as we mentioned, we also can manage all the different assets, IoT system, not just inside the meeting room, but also in the whole building. Like can be fire detectors, smoke detectors, temperature sensors, and things like that. So also we can track valuable assets that can be in the space, like can be, I don't know, for example, a video camera, or can be other important kind of assets that we have in our space. One use that is particular use that we can have with this, with the mix of now sensors, cameras, high bandwidth, is the barriers for entrance using face recognition. So the system will detect with a camera, a smart camera can detect the faces in a high speed. Okay, this is allowed now because Wi-Fi 6 gives us a better bandwidth and a better latency. Okay, so we can do on real time when the people pass through near the barrier, the system can recognize very quick if the people is allowed or not to enter. Okay? It involves a lot of data that can be managed thanks to Wi-Fi 6 problems. Now enter again in the production area. What we have is a normal question that some people do with their Wi-Fi 6. What is better for my environment? Have I to choose between 5G, narrowband IoT, Wi-Fi 6? The answer, as normal in these cases, is depend. It's a mix. The best combination is a mix of technologies. All of it will depend on many factors. Some factors will be the volume, how is it spread in the space, okay, the density of the things that we're going to connect, also the latency that we need. Technology from Huawei can help us to manage, for example, the AGVs, as we say, at a latency of as low as 10 milliseconds. Okay, it's the lowest one that we can find because the standard of the industry is 20 milliseconds. Okay, so everything above this 10 millisecond is recommended to go to Wi-Fi 6. Okay, when we have a space that is very clear defined and a density of some hundred of users or assets. Okay, if we need more density or even lower latency, or we have a bigger space to cover because well, the site is very big, difficult to cover with Wi-Fi, then maybe it's better to go to consider some alternative in the area of the mobility, like can be 5G or narrowband IoT. Okay, these are some of the uses that we can find in the industrial manufacturing that we also was mentioned, is the planning of the factory. In this case, we are helping with the high bandwidth and low latency. We are going to have the help to use tools based on AR or VR. Okay, also we have, as we mentioned, keep tracking of the different production tools, like can be the robots, things like that. The video can be a good supporter of the production, especially when we talk about high definition video or 8K, for example, that help us to keep the quality or see the quality that normal eye cannot see. Smart logistic is what we mentioned also previously, is the AGVs that are moving things from one place to another, robots, okay, and all the different sensors that we can find. Now we can see some more detailed uses. But also we have some challenges in the industrial environment. One of them are electromagnetic interference. We have high power machines that can generate these kind of interferences. Okay, Wi-Fi 6 is better protected than the previous technologies to do something like that. We mentioned many times is the delay and the jitter is more efficient on Wi-Fi 6 than was previously, so allow us to go more to real-time application. Also, the capacity to secure the network is something that is very deep involved in the Huawei solution for the Wi-Fi, including some new standard like WPA3 and things like that. Okay, and also important is Huawei cooperate, not just thinking on the Wi-Fi, but as we mentioned, in a joint of different technology that can work together. So it's important that they have similar uses or technologies, similar features. This is something that Huawei put emphasis in the development of 5G and Wi-Fi 6. One use case is the VR, virtual reality. Okay? In the past, to create a system or plan how to distribute a factory, you need to go pencil and paper. Okay? So it takes a long time. You need to create models, maybe on hand, drawing, use CAD. It's very difficult. Virtual reality is going to open a totally new paradigm for this. It's going to be very easy now for people to share, even on different sides of the globe, how the things are going to be integrated into the factory, okay? Or how the product is going to be seen previous to the production, okay? This is so important. In the same way, the augmented reality allows us to facilitate to some users, operators, the way that we do the industrial process. As we mentioned before, HK is also going to be a big driver. It means massive number of data for visual that will allows us to zoom to a very high detail scale to see the quality and the characteristic of a product or during the process. So we don't need the quality now, the quality check will improve a lot from the previous experience that was basically be seen on the capabilities of the human eye. For last, as we mentioned, is the AGV that will improve a lot the capacity of the logistic inside the factory. Okay? No longer we need to rely on human operators in the chain of process that if something goes wrong, well, you see here in a funny way, the mess that can be created. Now a lot, hundreds of automated vehicles can move over the floor in a better and more effective way. And for last is all the sensors. Now everywhere in the factory or in the industries will be covered of different sensors that are measuring a lot of different things during the process at a very huge speed. It needs a very reliable network. In this case, bandwidth is not important, but the latency and the capability to allocate a lot of this sensor, of this connection, then is welcome. And this is something that Wi-Fi 6 can provide that in the past was not possible with other technologies. Okay? For this case, Huawei have their own factories. As you know, we are a very big vendor, so our factories are in constant 24 hours working places. And we use all these technologies, and we gain a huge improvement using these wireless technologies in these factories. Okay? So we can say that we have saving of 14 million savings just in energy. Okay? 5% improvement in the global operation and 40% effectiveness decrease in the number of failures in the AGVs, thanks to this wireless technology that we involve in the factories. Okay, so we go a little bit more than this to use of the Wi-Fi and other wireless technologies. Is, as we mentioned from the very beginning, is the concept of the end-to-end. Okay, the wireless performance technology is very good, it's okay, but you need to consider the big picture. So you need to consider the end-to-end of all the chain of value. Okay, how you handle all the logistics of all the people across the system. So it's not just the Wi-Fi 6 AP, the radio management, is how you perceive, how you manage, how you program this, how you automate, okay, and how you detect some possible failures. This is also very important, and something that the Huawei solution include inside the cloud campus architecture. Okay, global scenario. As we have been saying, Huawei consider the end-to-end. We take care now of very large network. So it means that we need to move to a kind of cloud-based solutions that allow us precisely to see this big picture, to have hundreds, thousands of devices connected, bringing user, and see which is the way that the user react, possible issues, possible problem, and we can activate in a more automatic way all these kind of functions, features, and also detect possible problems, including security or network problems. At the end of the day, what we want is to guarantee that the different industries can manage a total life cycle of the production. Okay? from the design, the delivery, monitoring, okay, and go to market. And for this, they can rely on technologies as Wi-Fi 6. Okay, as we mentioned, what we are using is a concept to go for zero packet loss, zero delay, zero waiting time, no manual intervention, zero interruption, and zero risk. This is what we guarantee with the products of Wi-Fi 6 and the cloud campus architecture, not just for the industry, but for any kind of customer. And we're looking at the end, our vision is to go to an autonomous driven network. Okay, so the network can understand the environment and fix on itself and improve the ecosystem. And that's all. I hope that is useful, all this explication. I recommend to go and see the detail of the presentation that for sure can be downloaded. The indication will be provided. And thank you for your attention.
Thanks for joining us on day 2 of Huawei's Industrial Digital Transformation Conference. If you'd like to watch any of our live casts again, they'll be available very soon, right here. And of course, you can also explore the latest in ICT and more at e.huawei.com. I hope that I'll see you tomorrow, and thanks for joining us today.